Let's rewind to the earliest days of computing. Computers were room-sized giants, programmed not with keyboards but with punch cards, paper sheets with holes representing instructions. Programming was slow, error-prone, and required thinking like the machine itself. One mistake meant repunching an entire stack. This low-level approach made complex software nearly impossible. The need for a better way led to high-level languages in the late 1950s. Fortran, created at IBM, let scientists write code using familiar math, making scientific computing practical. Suddenly you didn't need to know the hardware to solve big problems. Fortran opened the door for a new wave of programmers. Soon after, COBOL arrived for business needs, managing payroll, inventory, and finances. Its English-like syntax made code readable, even for non-programmers. COBOL became the backbone of business computing, and many critical systems still rely on it today. These languages marked a turning point. Programming became more accessible and powerful. The leap from punch cards to high-level languages set the stage for everything that followed. Fortran and COBOL proved that software could be written for people, not just machines. This shift unlocked the potential for computers to transform science, business, and beyond. The era of modern programming had begun. Abstraction was the key, making code easier to write, read, and maintain. High-level languages were the foundation for the digital revolution, and they're still shaping the world today. The 1960s and 70s brought a wave of new languages, but one stood out: C. Developed at Bell Labs, C combined low-level power with high-level convenience. It let programmers control memory directly, yet write code faster and more efficiently. C's biggest impact? It made software portable. Rewriting Unix in C meant it could run on different machines, a revolutionary idea. C became the go-to for operating systems and foundational software. Its syntax and structure influenced countless modern languages: C++, Java, JavaScript, and more. Learning C is like studying the DNA of programming. Its balance of control and performance set the standard for decades. Even today, C's legacy is everywhere, shaping how we build and think about software. The conventions it introduced, like curly braces and variable declarations, are now universal. C is the blueprint for modern programming. Its influence is inescapable. As software grew more complex, object-oriented programming, OOP, emerged. OOP organized code into reusable objects, making big projects manageable. Java brought OOP to the mainstream in 1995, promising write once, run anywhere. Java's platform independence made it a favorite for enterprise and mobile apps. Meanwhile, open source was taking off, software anyone could use, modify, and share. This spirit led to Python, released in 1991. Python's clean, readable syntax made programming accessible to everyone. Its vast library ecosystem let people build anything from web apps to automation scripts. Python's simplicity and community support fueled its rapid growth. The combination of OOP and open source defined a new era of collaboration and innovation. Java and Python became pillars of modern development. They made programming more human-friendly and creative. The software world was opening up to all. Today, programming is more diverse than ever. The web dominates, powered by HTML, CSS, and especially JavaScript. JavaScript now builds everything from interactive websites to full server applications. At the same time, AI and machine learning are reshaping technology. Python leads the AI revolution, thanks to its simple syntax and powerful libraries like TensorFlow and PyTorch. Developers now choose languages based on the job: C++ for games, Swift for iOS, Dart for cross-platform apps. Specialization is the new norm. Each language solves a unique problem. The journey from punch cards to AI shows a constant push for better, more human ways to code. Fortran tackled math, COBOL business, C systems, Java platform independence, Python accessibility. Each step was about making programming easier and more powerful. Abstraction and collaboration drive progress. The story of programming is still being written. New languages and ideas keep emerging. The future is wide open.